Hi, this is Grover with Blue Collar Codes, the quick and dirty. I'm going to go over and summarize the episodes 2 to 5, the basic data types for you. If you'd like to follow along, click the link in the video summary to go to the GitHub repository and you'll find this Python file there. So let's get started over here in the terminal. Type Python and you get the interactive prompt. And so numeric types, basic and simple. You have integers and floats are the ones that we went over already. You do have complex numbers, decimals, and all that, but we're not going to get into that right now. Just the one thing to showcase is that if you're going to use an equation, it always goes to the result anyway, always goes to the highest level of precision. That's the type that will be output. So if you have a plus b, one of them being an integer, one of them a float, you get a float back. Something I wanted to fast forward and show you is the lambda function. So I'm going to import math here and just create a quick Pythagorean theorem calculator. And math, I'll do lambda a and b, math square root a squared plus b squared, and then just give you a test run here, and there you have it. So it's basically a one-liner mini function. It saves a bit on typing for small, say, calculations such as these, but it definitely, if you use lambdas in excess, it can be very confusing. So just memorize the syntax here. You just are assigning the lambda to a variable name, and then you're putting in your inputs that you need, and then you're using the actual keyword for those inputs to place them in your equation. And then in order to call the theorem and actually use it, you need to use the parentheses and put in those two values. Otherwise, it may error out. So other things we'll go over is the sequent types. So you have list, tuple, and sets. The list is probably one of the most useful. It can take any type, and it can be arbitrarily nested. So you can have a string, you can have an integer, you can have a float, then you can have a dictionary, and then let's see. And they are also mutable, which I'll showcase for you right now. So to access a variable, you're doing it by index number. So it's an ordered sequence. The one sequence that is unordered is the set, meaning that you can't access anything by index position. You'd have to do a search for that item. So here I got access to the A. I can change it in place here to a B, for instance. And then I'm going to showcase how you can access nested variables here as well. So you just kind of stack the square brackets. So I'm going to do index position 0, 1, 2, 3 to get access to the dictionary. And then I'm going to access the A within that dictionary. And then I'm going to assign that a list. And now I'm going to change that list's second value to a 10 for you, just to go further into the nesting and just showcasing you that it's endless. You can continue to do this as much as you need to. However, for tuples, you can index them. So that's the last place. So another thing to show you is, since I know that's the last item, I can index it like that. And then I can index, say, the last item in that tuple, and I'll get the 3. So that'll be returned, the value. But if I wanted to alter that, that's what it means to be immutable, in that you cannot alter it. Once it's been created, that is it. And there is no removing and adding, changing items. So you just have to delete it or just overwrite it. I'll showcase that for you. So -1, -1, so that would be the 3 again. I want to change it to a 4. It's going to error out. But, so we accessed it by index, just using, so the last position in the list, the outer list, and then the last position in the tuple, and returned the 3. But we tried to assign something, it didn't work. So now to kind of just showcase the significance or the differences between the set and the list, for instance, the set doesn't allow duplicate values. As you can see, it just automatically weaned it down to just the unique values. So I'm going to assign it this time so I can try to index a value. So 1, 2, 4, 5. I got rid of that second 4. And then I'll try to index the 1 there, and you can't index. So that's what I wanted to go over for the sequence types and numeric types. Oh, one more thing is that the list L, I can add to the end of it the function we created, so it can house functions and classes as well. And just an FYI that this is how it's going to look. You will not be able to access it by this name that you gave it, the variable name. At least if you add it to the if you add it to the list in that fashion. So now that I've reached and gummed up the works here, I'm just going to type in the word clear, and it'll clear the console up to the point just to give you a clear screen. So now I'm going to go over strings. So you can create strings in either fashion, either with single quotations or double quotation marks. If you wanted to have them show up within the string, say the quotation marks, you can either escape them, so I'm going to reassign that, and I want to put, I'm just going to make a random string here. So this works because I'm using single quotations on the outside and then a double quotation on the inside, or vice versa will work. But let's say you had more complex quotes to do, or you wanted to do an apostrophe, you would have to use an escape, meaning it's just a backward slash. So S equals we and you'd have to do that for every one. So as you can see now, the apostrophe was in there, and then fun maintained those quotation marks. And here the output is putting the double quotation marks, but that's not necessarily the case. It's not something that will be picked up, as in it's just doing it to show you that the output is a string, but it's not actually in the string itself, if that makes sense. So I wouldn't get confused with the output in the interactive prompt in that fashion. So the other thing to note about strings would be the slicing. And so let's say I'm going to rename it to string, and I just want a slice of the TRI. Remember that the first place is inclusive, so I want to do it at the starting point, the exact starting point, and then the ending one is exclusive, meaning I want to do it one past where I want to end the slice. So here I want TRI, so I need to do 0, 1, 2, 3, the 4th index position, one past. And then I have the TRI. And then also there's stepping. So if I wanted to get the first character, then every other character, so S, R, N, and then it would fall off the ledge there, I would do just stepping by 2. And there you have it. Outside of strings, you have the dictionaries. You can just create a dictionary with the curly brackets. One thing of note is that you can put any immutable type as the key. It can't be immutable. It can't be mutable, however. So I can't do this. It'll error out because I'm putting a list there and then trying to assign it to something. Mainly because of the whole it can be changed in place. So then what is it actually referencing if that list has already been changed by another operation somewhere else? Then it would become, just error out anyway because it'd be an invalid reference at that point. Or it would be just a mess because they'd be constantly changing, and how would you be able to index them at that point? Or pull them up via keyword value pair. But you can use, say, tuples because they're immutable. Once you create them, that's it. And then you can do floats. And so just understand the utility behind that, and that, I don't know, if you want to do points on the Cartesian plane, or, points in 3D space or something like that, you'd be able to use tuples and then, I don't know, put RGB values or something like that for pixels or what have you. That'd be a way. That's a utility of it, potentially. So closing that out. So you can do any immutable type. So mainly strings, floats, or integers, or numeric types that are immutable, and then you have the tuple. And so now, one more thing that I'll go through is just a simple looping, a way to loop through a dictionary, because I find it useful. You can loop through the keyword value pairs at the same time. So I'm just going to alter it to a more simple dictionary anyway. Just because then it's less typing. So for key value and d.items, well, first of all, let me create an empty one just to show you that, for instance, if you wanted to change all of these, pretty much make a 1 attributed to an A, like switching the values for the keywords and then vice versa. That's what you could use items for if you wanted to gain access to the keys and the values at the same time to create a different dictionary. That would be transposed. So for key and value in d.items, I'm going to do e value equals key. And now e is that transposed. Now you just have to be careful that everything was immutable. All the values would be immutable. Else you would have to check for types before you tried to assign a keyword, and then segregate the ones that were mutable. So now I'm going to go over this problem kind of live for you. You might see me make some minor mistakes and work through them, but it'll kind of showcase what you need to do to solve these problems as well. So the first things first is you want to know what your goal is, and that is I want to just have address labels here. But unfortunately, and this may be a real-life example for you in some form or fashion, not all this information is organized in the best way. So you just have a string of names, so I don't have access to the last name, so I can't necessarily immediately loop through and get the street, the zip code, and then loop through to get the zip code, and then the city and the state. So I need to do some alterations to this first. So what I'm thinking is, since I want to have access to John and Doe, Jane and Smith, what I'm going to do is make a dictionary from this string that's going to have last name as the keyword, and then the value is going to be the first name. Now this might not work in all instances because you might have repeat last names, so you would have to find another element that is entirely unique to differentiate. And that's why a lot of times you'll see databases have unique identifier numbers for, say, customer number. So that's the ultimate way, or the top level way, of differentiating between people that have similar information. So here, I'm going to make it from I'm going to use a comprehension. So what you'll find is you'll see that I have code completion here, in that I do have Copilot. I wanted to test it out to see what its utility was, which I'll probably make an episode about in the future. But as of right now, it's definitely useful for certain things, especially if you have redundant, say, functions or redundant things to write and type, but it's not entirely useful when things start getting detailed. Not yet, anyway. So first of all, one recommendation, even though sometimes I find that I don't follow it very well myself, is that after each thing that you're trying to attempt, everything can be broken down into subtasks and minor things that you're doing in minor functions. So you would want to test it first. Before you're going to write your whole thing and then try to debug the whole thing at once, why don't I make sure that first this is accurate? It's splitting how I want. And so I'm going to hit save. So that's also a thing you need to note about VS Code. You're always going to have to hit save, Control S, and then for me I have some macros, like Control Alt N is what will print it. Let me see here. Invalid syntax, huh? X is split. For X in full names, let's split. First of all, let me clear this. Control S. I don't think I'm doing anything as far as invalid escape sequence, huh? I must have typed something here incorrectly. Strange. Just because usually something would come up, as in where's the error? So was it just pass? Let's see. So I guess this is a live example of something I'm doing wrong here. Maybe I have something going on. So let me close out all the terminals. Let me save this again. Okay. I think that was like a leftover from an old console that I had open, or old terminal, when I was maybe foolproofing this problem out or something. So apologies for that. There you have it. So it was correct. There was no real error in my code. There was another terminal open for this same file that had something incorrect in it, or had something, I couldn't tell you exactly, since I had just closed it out and that worked without changing anything here. But anyway, here you have proof of that my dictionary comprehension did as I wanted. You have Doe and John, you have Jane and Smith, you have Jack and Dane. And then, so now I have access to a list of keys for all of these names by last name. And now at least I can access all of these. However, unfortunately, I don't have access to these because it's just a tuple of tuples, meaning I have to loop through this separately and check it against this keyword if I want to have an enclosing loop. Or what I would need to do is use this to be my core looping structure, and then use data from this to access everything else. So maybe that's what I'm going to do. So in this way, I'm going to go do, so this is also showcasing a bit of for loops. So I'm going to do for name tuple in zip codes by last name be last name equals zip code use name tuple 1. So that's this would be one thing that could be useful with Copilot as well. You know, it kind of anticipates what I'm looking for, but I'm not going to use it right now anymore to showcase you what you're probably going to have to do. So basically now I'm using the last name to gain access to all of the values. So here I'll do full name is going to equal names last name plus the space plus last name. And then street will equal streets by last name, index by that last name. And then you have the city equals city and state. So now I'm going to have a template, and we'll go over the string formatting a bit. And in this instance, let's use, since I'm not using anything other than full name. See, that's where it's helpful. Like, I don't have to do all this typing, but I will do it for you to showcase what you're going to have to do. Well, if you could only type city. Up. So this is not coded super effectively because I'm using these escapes. What I could do instead, sorry, not these escapes, using this type of string formatting with a percentage sign, with a modulus, what I would do instead is I would probably, so template 2 equals, because you can, instead of having to, so essentially when you use triple quotes, your paragraph and formatting of the spacing can be maintained as if it's making a quote of the string within it. However, you can accomplish the same thing by just using the new line character, as it's already doing here for me. And it saves on code because you don't necessarily have to use the template and then put all these list of variable names in it. Or if I wanted to do it this way with a percentage sign, then I should have just created a dictionary as I was going along. So, but that's why for me the F string is probably much simpler and easier to code. So as you can see, even for some reason it's giving it formatting. And maybe this is a case in point for not using. So this is automatic. All I did was type enter in there. So it maintains this because of the editor, this line where they're all not just going all the way to the edge here. Because one, it can't because it would be outside of this function. That's another thing that we'll go over, is how Python's syntax needs to be maintained in order for it to understand the code. But let's see what this comes up as. So it's coming out to be the same thing. So even in this instance, it'd be better to use just an F string, and then you get the example you want. But as you can see here, I was able to achieve all of these address labels by just looping through everything once, where I did solve it on another occasion where I tried to loop through the names, and then I did a nested loop and looped through these, where that's much worse as far as big O and time complexity is concerned, which is something that we'll get into in a later video as well. So next, what we're going to go over is, in episode 6, is going to be the files and how to open them, write to them, and then go a little bit into using JSON. So hopefully this was somewhat informative. I made this a much longer video than I'm going for in the normal episodes, just because it's a summary video and I wanted to go through a problem for you and showcase how to work through changing data and going through more into loops without formally having gone over looping as of yet. So again, Grover with Blue Collar Codes, the quick and dirty. Thank you for joining.